The future is built, literally. What's up guys, David here, and welcome back to the channel. If you look around, everything you see, the house you're in, the office you work at, the bridge you drove over this morning, was built by someone. For centuries, the basic formula has been pretty much the same. Dig a hole, pour some concrete, stack some bricks or wood, and repeat. It's a process that's reliable, sure, but it's also slow, expensive, and sometimes pretty dangerous. But what if I told you that entire formula is about to be completely rewritten? We are on the brink of the biggest revolution in construction since the invention of the steel beam, and it's happening right now. The world of construction is getting a massive tech upgrade, and it's not just about fancier tools. Think about how much your phone has changed in the last 10 years. Now imagine that same level of exponential growth happening to the buildings all around us. It's like we've been building with Legos, and someone just handed us a Star Trek replicator. The speed, the materials, the very intelligence of our buildings is evolving at a mind-boggling pace, and it's going to change everything. So today we're going on a deep dive into the absolute coolest, most game-changing construction innovations set to take over in 2025. All right, first up is something straight out of a sci-fi movie, 3D printed buildings. Now, you've probably seen those little desktop 3D printers making plastic toys or phone cases, right? Well, imagine that, but scaled up, way up. We're talking about a massive gantry, basically a giant robotic arm that moves back and forth over a foundation, squeezing out a special concrete mix layer by layer. It's like watching a building grow right before your eyes, following a digital blueprint with perfect precision. It's not just a concept, this is happening right now, all over the world. The real magic here is the speed. A traditional crew might take months to frame and build the walls of a house. A 3D printer, it can print the entire structural shell in a matter of days, sometimes even less than 24 hours. Think about the implications for disaster relief. After a hurricane or an earthquake, we could potentially print entire communities of emergency shelters in a week. By automating the most labor-intensive part of the building process and minimizing material waste, the costs can plummet. Because the printer is guided by a computer model, you can create complex curves and unique architectural shapes that would be incredibly difficult and expensive to build using traditional methods. The proprietary concrete mixes they use are often stronger and more resilient than standard concrete. We're talking about multi-story apartment buildings, office complexes, and even infrastructure like bridges being printed on site. It's not a question of if, but when you'll see a printed house in your neighborhood. Okay, this next one sounds like something a supervillain would invent, but it's 100% real and it's for the good guys. I'm talking about self-healing concrete. Let's be honest, concrete is everywhere, but it has an Achilles heel. It cracks. Water gets in, freezes, expands, and turns tiny cracks into massive problems. This is why our bridges, roads, and dams constantly need expensive and disruptive repairs. But what if the concrete could fight back? What if, when a crack formed, the concrete could just heal itself? Researchers have developed a few different methods to do this, but one of the coolest involves embedding tiny capsules of bacteria within the concrete mix. When a crack forms and water seeps in, it ruptures those tiny capsules. This wakes up the bacteria, and they get to work. As part of their metabolic process, they consume a calcium lactate food source and secrete limestone or calcite. This limestone fills the crack from the inside out, sealing it up and preventing further damage. The impact this could have on our infrastructure is staggering. Imagine a bridge that, instead of deteriorating over 50 years, could last for 100 or even 200 years with minimal maintenance. This isn't just about saving money on repairs either, it's about sustainability. The production of cement is a huge source of CO2 emissions, about 8% of the global total. So stronger, longer-lasting buildings also mean a healthier planet. It's a massive win-win. This brings us to our third innovation, modular construction. This is high-tech, precision-engineered construction that happens in a factory. The basic idea is to build entire sections of a building. We're talking full rooms with walls, floors, windows, plumbing, and even electrical already installed in a controlled environment. Once these modules are complete, they're wrapped up, loaded onto trucks, and driven to the actual construction site. There, a crane lifts each module into place. They're connected together, kind of like stacking giant high-tech Lego bricks. A multi-story apartment building can be assembled on-site in a matter of days or weeks. The efficiency gains are just mind-blowing. Projects can be completed 30% to 50% faster. Factory construction creates significantly less waste. Leftover materials can be easily sorted and recycled. The precision of the build also leads to much tighter, better insulated buildings, which means they use less energy for heating and cooling over their lifetime. By 2025, we're going to see this method become the standard for all sorts of buildings, from single-family homes to high-rise hotels and apartment complexes. Construction sites are, inherently dangerous places. For decades, the main piece of safety gear has been the hard hat, a simple piece of plastic meant to protect you from falling objects. Well, that's all changing now. Say hello to smart helmets and a whole bunch of wearable tech that's turning the average construction worker into something like a real-life Iron Man. We're talking about embedding it with all sorts of sensors and tech. Imagine a hard hat with built-in GPS tracking a worker's location on a huge site, super important in an emergency. Add in sensors that can detect a fall or sudden impact, and get this, automatically send an alert to the site supervisor with the worker's exact spot. These helmets can have integrated sensors to monitor the worker's vital signs like heart rate and body temperature. Think smart vests with built-in lights for better visibility and proximity sensors that vibrate to warn a worker when they're too close to heavy machinery. Or smart boots with sensors that can pick up on hazardous chemicals or electrical currents. Some smart helmets have augmented reality visors built right in. An electrician could look at a wall and see a digital overlay of the wiring schematic. The data from these wearables is also super valuable. It's about using data to make construction one of the safest industries, not one of the most dangerous. When you think about a construction site, you probably picture a lot of manual labor, people lifting heavy stuff, tying rebar, laying bricks. But for a robot, they're kind of the perfect gig. One of the coolest examples is the bricklaying robot. We're talking about an automated arm that can lay bricks with crazy speed and precision, way faster than any human mason. A human still needs to supervise and load the machine, but the robot does all the back-breaking work. Think of the Boston Dynamics Spot robot dog, but made for a construction site. These robots can walk over rough ground, climb stairs, and carry tools or materials. Demolition is another area that's perfect for automation. Imagine a remote-controlled or even autonomous demolition robot that can go into an unstable building. By 2025, a construction site might look more like a choreographed dance between humans and machines. The robots are here to help, not to take over. For a long time, the go-to materials in construction have been concrete and steel. They're strong and reliable, but making them comes with a pretty hefty environmental price tag. One of the most exciting is mass timber, specifically cross-laminated timber, or CLT. Think of it as plywood on steroids. And the best part? Wood is renewable. As long as it's sourced from forests that are managed sustainably, it actually sequesters carbon. Then there are materials that are literally grown. I'm talking about mycelium, which is the root structure of mushrooms. You can take agricultural waste, pack it into a mold, and add mycelium spores. And then there's hempcrete, a mix of hemp herds and a lime-based binder. The innovation isn't just in the materials themselves, but also in recycling. There are even smog-sucking bricks and paints with titanium dioxide, which reacts with sunlight to neutralize pollutants in the air. The idea of a circular economy is really catching on in construction. It's about making buildings that are healthier for the people inside them and for the planet as a whole. Okay, so imagine you're about to build a billion-dollar skyscraper. But before you even break ground, what if you could actually build the whole thing in a totally simulated virtual world? That's the power of digital twin technology. And honestly, it's one of the most powerful project management tools ever created. This digital version is hooked up to the real-world building through sensors. Data from the physical building gets fed right back to the digital twin in real time. Architects, engineers, and construction teams can all work on the same master model. They can run simulations to spot potential clashes before they happen. You can simulate different construction schedules, test the energy performance of different materials, and optimize things like never before. Because the digital twin is constantly updated with real-world data, it becomes like the ultimate owner's manual. It's about creating not just smart buildings, but buildings that have a digital consciousness, constantly learning and adapting to be as efficient and resilient as possible. For decades, surveying a large construction site was a slow, labor-intensive process. But now, we have a much better tool for the job: drones. These unmanned aerial vehicles are revolutionizing site surveying, making it faster, cheaper, and way more accurate. This data is then uploaded to a software platform that uses a process called photogrammetry to stitch all those images together. It creates a complete, high-resolution, and geographically accurate model of the entire site. This provides project managers with an unprecedented level of insight. Instead of sending a worker to inspect a steep embankment or the top of a bridge, you can send a drone. This keeps workers out of dangerous situations while still getting the detailed inspection data you need. As we head into 2025, using drones for surveying and monitoring will be as common on a construction site as a bulldozer. We've talked about digital models, but what if you could take that digital model and overlay it onto the real world? What if you could stand on an empty plot of land, put on a pair of special glasses, and see the finished building right in front of you at full scale? VR on a construction site, this is an incredibly powerful tool for visualization and planning. Imagine a team of electricians and plumbers walking through a building that's just been framed, wearing AR headsets. They can see the full-scale, three-dimensional models of all the pipes, conduits, and ductwork projected exactly where they are supposed to be installed inside the walls and ceilings. A foreman can walk the site and compare the work that's been installed against the digital model overlaid on top of it. They can immediately spot if a pipe is in the wrong place or if a wall was built a few inches off. AR is also an amazing tool for communication and collaboration. An architect in New York could join a virtual walkthrough of a site in London. We'll see it used for everything from training new workers by providing step-by-step visual instructions to safety briefings where potential hazards are digitally highlighted in the environment. What if a building wasn't just a consumer of energy but also a producer? We're all familiar with solar panels on the roof, but that's just scratching the surface. The next frontier is to turn the entire skin of the building, the facade, the windows, everything, into an active energy-generating surface. This is the world of energy-generating facades, and it's turning buildings into their own power plants. Researchers are developing piezoelectric materials that can be incorporated into facades and even floors. These materials generate a small electric charge when they are subjected to mechanical stress. Another fascinating area is thermochromic and electrochromic windows. These smart glass windows can change their tint in response to temperature or an electrical signal. As we look to 2025, the combination of these technologies will allow us to design net zero or even net positive buildings. Buildings that produce as much or more energy than they consume over the course of a year. Our buildings will stop being passive shelters and will become active participants in a sustainable energy future. So there you have it, 10 innovations that are completely reshaping how we build our world. From self-printing houses and self-healing concrete to robotic workers and buildings that power themselves, the future of construction is more exciting than I ever could have imagined. This isn't just about building things faster or cheaper. It's about building them smarter, safer, and more sustainably. But now I want to hear from you. Which one of these innovations blew your mind the most? Let me know down in the comments. And if you enjoyed this look into the future and want to see more content that explores the cutting edge of science and technology, make sure you hit that subscribe button and ring the bell so you don't miss the next video. Thanks so much for watching, and we'll see you in the next one.